Hey Algebra 2, I hope you printed out this sheet to help you complete your notes better. Today in this video we're going to be talking about 7.4 Day 1, graphing sine and cosine functions. So let's just get right into it. The length is the length of one cycle. That is going to be the period. The axis is the line halfway between the maximum and the minimum values of the function. And it is always written as an equation. And yes, you need to label it on your graph. The amplitude is the distance from the axis to the maximum. Or minimum values of the function. Alright, so when we're graphing sine, given these x values, these are all angles. So to figure out the y values, we're going to do what's sine of negative 2 pi. So sine of negative 2, find the y value, right, is 0. Sine of negative 3 pi over 2 is 1. Sine of negative pi is 0. Negative pi over 2 is negative 1. Sine of 0 is 0. Sine of pi over 2 is 1. And you probably are noticing a pattern. So when you are graphing, right, we want to graph each part of this function. So we want to graph the axis and plot points. So the first thing I always recommend doing is plotting your axis. So it's going to fluctuate between x and the y-axis. So this is y equals 0. And we'll plot our points. So we have negative 2 pi 0, which I guess we could do this first. My coordinate plane is in degrees, but we know that this is negative 2 pi, negative 3 pi over 2, negative pi over 2, 0, pi over 2, pi, 3 pi over 2, 2 pi. Right? Okay, so we'll be at 0, and then 1, because that is radius, 0, negative 1, 0, 1, axis, min, axis. Okay. The sine function is a curve. So you're going to go up and then down and curve to go back up. Okay, and I'm going to keep following this pattern. So this is where we start for the sine function, 0, 0. The amplitude, to kind of go over some things, the amplitude, like we color-coded in orange, is the distance between the axis. So this is our axis. In this case, it's the x-axis, but there is the axis of the function. So that's this distance or this distance, which is 1. So that's the amplitude. Right? A period is how long it takes to complete one cycle, so we did that in pink. So the period is going to be 2 pi, which is also going once around the circle. Right? And you'll notice when you look at your function, right, that's where it starts to repeat itself. So it's going up, down, and now at 0 it's going to start going back up and following that pattern. Okay, so a few things to take note. The domain for this function is negative infinity to infinity, or all real numbers. The amplitude of this has a distance of 1. The range is hard bracket because it is included -1 to +1. The period is 2 pi, or 360 degrees. The y-intercept is 0, 0. And the equation for the axis is y equals 0. So the sine function, sine of x, begins on the axis and goes up. So the parent starts on the axis and then goes to the max. So that is important. Okay, now let's talk about cosine. So cosine is going to be super similar. If I use what I know from my unit circle, we're going to have 1, 0, -1, 0, 1, 0, -1, 0, 1. If I plot all these points, -2 pi, right? So you notice here the pattern is very similar, but a little different. So because sine of 0 is 1, our function starts at a maximum. Right, and the curve looks super similar and follows a similar pattern of max, axis, min, axis, max. Now, just a little thing to note, because my coordinate plane ended on a max, or if it ended up on a min, you don't want to put it going up, you want to show that it's turning to come back down, or else that might be confusing and make it seem like it's a polynomial. So here is our starting point of 0, 1. The domain is still -infinity to +infinity, or all real numbers. The amplitude is still 1. The range is hard bracket, -1 to 1. The period is 2 pi, or 360. The y-intercept is 0, 1. And the axis is also y equals 0. So where does the graph of cosine begin? It begins for cosine at the max and goes down. And if you understand, right, when we think of the unit circle, right, this starts at 1, that's a good way to remember that it starts at the max. So, putting all this together, there are different parts. I'm going to talk about what part affects certain key points. So, A, the number in very front, that's being multiplied by the function, is the amplitude, A for amplitude. And the amplitude is like a vertical dilation. But we prefer amplitude when we're dealing with sine and cosine. B is like a horizontal dilation, but we're going to think about it as helping us find our period. Helps determine period. You can think of it, yes, it is a horizontal dilation. So to find your period, there's actually a formula. So if you're in radians, it's 2 pi times 1 over b. Or if you're in degrees, it's 360, that's a weird 3, times 1 over b. Okay. So let's talk about, oh, before that, almost missed it, it's right in front of me. How do you determine the distance between the key points? This is really important. So the distance between your max, your axis, your min, your axis, right? The key points, you want to do your period, you're going to divide it by 4. Okay. All right, so steps for graphing. The first step you are going to be required to do is list the following: your axis, your amplitude, and your period. And your period you need to solve for and show that. And I did say show. Hopefully you're paying attention. All right, the second set to graphing, you want to find the distance between your key points. The third step is to graph, and don't forget to label your starting point. And you should try to graph about 2 cycles, or take up the window you're given. When I say take up your window, that's the size of your coordinate plane. Okay. All right, so let's do an example. So here we have 3 times cosine of 2x. So first thing we need to do is list. We want to list the axis. So if we look at our equation, our axis, I'm going to actually include this, but the axis is just going to be y equals 0 for now. The amplitude, we did talk about this. The amplitude, because it's 3 times cosine, is going to be 3. Our period, so to find our period, it's 2 pi times 1 over b, and our b value is 2. So the 2's cancel, and we're left with just pi. And then the distance between the key points, right? We take the period, which is pi, and we divide it by 4. So this is the distance between your axis max, axis min. So that's what you want to use to make your scale. So you'll notice this is blank. You're responsible for creating your own scale. So we're going to want to go up to 3. I'm going to have this be 3. And then we need to make our scale. So I'm going to have it be every other one. So I'm going to have this be pi over 4. And then this be 2 pi over 4, or pi over 2. 3 pi over 4. 4 pi over 4, pi. 5 pi over 4. 6 pi over 4. And then 7 pi over 4. Oops, 7 pi over 4. Alright, same thing going the opposite direction, and make sure your scale is consistent. Sometimes students mess that up. Okay. So because this is cosine, cosine, remember, starts at the max. So our first key point is going to be at 0, 3. I'm going to circle that to label it as my starting point. You could even label it 0, 3 if you want. And then we always go from our axis to our max to our axis. We need to make sure we go the distance of pi over 4, which is why I've marked them as such. So I'm going to go here, axis, go over distance of pi over 4, min, axis, max, axis, min, axis. And then going the opposite way, axis, min, axis, max, axis, min. Okay, when I'm making my curve, I'm going to want to make sure it's curved here since that's a minimum. We don't want it to look like we're going straight. We're going to connect our key points. Oh, crap. Well, that's a shame. Luckily, I've already done it. We're almost out of time. So here's it plotted correctly. And I also forgot to graph the axis, which I was going to do after. So that is the function. And we will be doing some more practice with this.